Today we're going to be talking about linear relations and linear functions. And I have examples on the left here of linear equations. And hopefully you guys realize that a linear equation can be written in the form y equals mx plus b. Remember, m is slope and b is the y-intercept. So if you can solve for y, and the power on x is 1, and x is essentially, the equation can be written in this form, it's going to be a linear equation. Some examples of nonlinear equations. This first one, the y is being squared. The next one, we have this square root sign. The next one, x's and y's are being multiplied together. In the fourth one, the x is in the denominator. Okay, so linear equations only have addition, subtraction, and multiplication of a variable by a constant, so no division. Variables must not be multiplied together. So this third example in our nonlinear. No variables in the denominator. And then lastly, no exponents greater than 1. So we had an exponent here that was greater than 1, or a radical function, or a different function. So that's how we know whether or not we're going to have a linear equation. Okay, state whether each is a linear function, write yes or no, and then we have to explain. So the first one here, A. Yes, this is a linear equation because it can be put into y equals mx plus b, where m in this case is 2 and b is equal to negative 5. Part B. No, this is not. Why not? Because of the x cubed term. And that's all you need for your explanation. The next one. Is this in y equals mx plus b form? Yes, it is. We just have to switch around this negative 8x term in the 4. So yes, because it can be put into y equals mx plus b, where m in this case is negative 8 and b is a positive 4. And then our last example, is that a linear function? Well, we have x having a power of 1, but notice how x is in the denominator. So this one is no, because x plus 3 is in the denominator. Okay, our next example. And yes, I want you to write all of this down. The linear function f of c, where we have a function of the variable c, can be written to find the number of Fahrenheit degrees f of c. So this is standing for Fahrenheit that are equivalent to the given number of Celsius degrees. On the Celsius scale, the normal body temperature is 38 degrees Celsius. What is the degrees in Fahrenheit? So I need to find f of c. I need to find f of our function evaluated at 37. So what I do, this equals 1.8 times 37 plus 32. And it's okay if you do that work in your calculator. I pulled out my calculator and did this work in my calculator. So that's going to be 98.6 degrees Fahrenheit. And make sure you give me units. Now part B. There are 100 Celsius degrees between freezing and boiling points of water, and 180 Fahrenheit degrees between these 2 points. How many Fahrenheit degrees equals 1 Celsius? So I know that if I have 100 degrees Celsius, that's going to be the same thing as 180 degrees Fahrenheit. If I divide essentially by 100, that cancels out, and I just have 1 degree Celsius on the left. When I divide there, I have 1.8 degrees Fahrenheit. So 1.8 degrees Celsius refers to 1.8 degrees Fahrenheit. And I wonder if there's any correlation between that 1.8 there. Standard form. This form is going to be super helpful to us when we get into a later chapter and we're graphing equations that are given to us in standard form. So that's why it's important that you guys know how to graph this. So it's ax plus by equals c. Ax plus by equals c, where a, b, and c are integers with the greatest common factor of 1, so they all need to be essentially reduced, and a is greater than 0. Another way to think about it, a has to be positive. And a and b are both non-zero. So in our example here, 3x plus 5y equals 12, we have a, we have b, and we have c. So in this example where I need to write the equation in standard form, we essentially need to get rid of these fractions. So what number can I multiply by that's going to get rid of those fractions? Or what's the least common multiple of all 3 of those numbers? Well, that's going to be 6. On the right side, we have 3y. On the left side, we have 4x plus 5. Now I need a to be positive. So this 4x term has to be positive. So I'm going to leave it on the left side. What I'm going to do is I'm going to subtract the 3y over. I'm going to subtract the 5 over. So then this is our standard form, where a is equal to 4, b, the coefficient on the y term, is negative 3, and our c term is negative 5. Okay, x-intercept, the point where our graph crosses the x-axis. If something crosses the x-axis, think about what the y-coordinate would be. Our y-coordinate for any point on the x-axis is 0. So we find our x-intercept by making y equal to 0. Our y-intercept, any point on the y-axis, think about what the x-coordinate is. The x-coordinate is 0. So we find the y-intercept by making x equal to 0. So I need to find the x and y coordinate, x and y intercept of the graph. What I like to do is I like to make what I call an xy chart. Make x 0, make y 0, my intercept chart. So if I make x 0, this term goes away. So now I'm just solving this equation. If I multiply by a negative 2, because that's going to cancel out and I'm going to get my y to be negative 6. So I have 0, negative 6 for this is my y-intercept. Now, I erase my work here, and I find I make y 0, that's going to give me my x-intercept. So if I make y 0, that term goes away, because 0 times anything is 0. I multiply then by 4/3. So x, therefore, is going to be 4. So I have the point 4, 0. And then, if I'm graphing this, I just connect to these 2 points. And again, if you understand what those 2 intercepts are, that's going to make your life a lot easier in a few chapters. And also, if you look originally at this equation, I know we haven't talked about y equals mx plus b yet, but this would be a really hard equation to change into y equals mx plus b, as of all those fractions. So it actually kind of makes our life a little bit easier. Okay. Your lesson questions. You have 3 lesson questions for today. Please make sure those are submitted on time.